Hi everybody, today we're starting to look at differential equations, and our main look at that is ordinary differential equations. So first of all, let's just step through what this means. So a differential equation is an equation involving a derivative. Now an example of that could be something like dy dx, that's my derivative, equals, that makes an equation, something like 2x. Now the point with a differential equation is to find the original function. So I've got the derivative, so what is my original function? And so you can see that integration is a very important part of differential equations. So if I said that dy dx is equal to 2x, then my original function would be y equals x squared. I've made a mistake there, that there'll be no 2 out the front, but rather it will be x squared. So that's the point of a differential equation. Now an ordinary differential equation is where there is only one independent variable. So if we consider the equation dy dx equals something like 2xy, well, y is the original function. So that's the dependent variable, and so x is the only independent variable. So that's an ordinary differential equation as compared to something like dy dx is equal to x zy. In that case, both of these are independent variables. And so that's not an ordinary differential equation. Okay, so the first type of differential equation we're going to look at is separable. So a differential equation is what we call separable if it can be written as a product of two functions. One function is in terms of the variable we are differentiating with respect to, so that's like the dx in the dy dx, and the other function is in terms of the variable representing the original function. So dy dx is equal to f of y, function of the variable representing the original function, times by g of x, function with the variable being what we're differentiating with respect to. So if we bring the f of y to the other side, then we have 1 on f of y, should be f of y, not f of x, dy dx is equal to g of x. Then we're going to integrate both sides with respect to x, and we're going to find that dx's cancel. So if I have the integral of 1 on f of y dy dx with respect to x, and the other side is the integral of g of x dx, those dx's cancel, and so I get the integral of 1 on f of y dy equals the integral of g of x dx. And so then we can solve for y by integrating both sides. Okay, so let's have a look at a couple of examples. down there at the bottom of the page. And so the first one is dy dx is equal to x 1 plus y e to the power of x. Okay, so that's my first example. And let's have a look at how we might do this. So I need function of x times function of y. So I'll get function of x. That's going to be x e to the power of x. And I'm going to put it in brackets so we can clearly identify that. And then the function of y is going to be 1 plus y, and that's already in brackets. So then I bring my function of y over to the other side and divide through it. So I get 1 on 1 plus y dy dx is equal to x e to the power of x. And then I integrate both sides with respect to x. So I integrate 1 on 1 plus y dy dx with respect to x to the integral of x e to the power of x dx. Dx is cancelled, and so I'm integrating 1 on 1 plus y with respect to y and x e to the power of x with respect to x. Okay, so after that, integrating the left-hand side, well, that's ln. Now that's a linear argument inside the function there, so it's ln of the modulus of 1 plus y, and we're dividing that by the derivative of 1 plus y, which is just 1. So it'll be ln of the modulus of 1 plus y all over 1 plus c. And then that's equal to, now out here, we're going to say u is equal to x, so u dash is equal to 1. V dash is equal to e to the power of x, so v, this is using integration by parts. So I'll have x e to the power of x, take the integral of 1 times e to the power of x dx. So it's ln of the modulus of 1 plus y plus c is equal to x e to the power of x minus e to the power of x plus c1. And then the final thing to do is to rearrange this in terms of y, because we want to find what y is. So it's a little bit of work involved, but if I move the c's to one side, I'll have ln of the modulus of 1 plus y is x e to the power of x minus e to the power of x plus c2. And then I'm going to have to raise both sides to e. So I'm going to have the modulus of 1 plus y is equal to e to the power of x, e to the power of x, minus e to the power of x plus c2. Now, we've got our constant here. So this next bit takes some work, but if I think about the modulus of 1 plus y, I can break up this power as e to the power of x to the e to the power of x minus e to the power of x times by e to the power of c2. Now e to the power of c2 is just some constant which we call a. So we have it at the front as a e to the power of x, e to the power of x, minus e to the power of x. Now to rearrange for y, I need to make the right hand side plus or minus. So it will be 1 plus y is equal to plus or minus a e to the power of x, e to the power of x, minus e to the power of x. Now, because we've got plus or minus, well, that can just get absorbed into the constant. So constant a can be positive or negative. So the plus or minus is not needed. It's just absorbed into the a because that a can be plus or minus, so that takes it into account. And then moving the 1 to the other side, so we'll have y is equal to a e to the power of x, e to the power of x, take e to the power of x minus 1. And yes, it's a slightly complicated function, but it works. Alright, second example. So if you need to just finish copying that down, just pause the video. I'll leave it up there while I'm writing down the second example. So this is also at the bottom of your sheet. So it's 1 plus x squared dy dx is equal to 1 plus y squared. Okay. Now, it's always important to have the function where the variable is the original function on the left-hand side, and the function with the variable that we're differentiating with respect to on the right-hand side, so that when we cancel out our dx's, we ensure that we get left, so we're differentiating 1 plus y squared with respect to y. So I need to swap the sides that these are on, so I'll divide both sides by 1 plus y squared. So I'll get 1 on 1 plus y squared dy dx is equal to 1 on 1 plus x squared. So then I integrate both sides with respect to x, so that's 1 on 1 plus y squared dy dx is equal to the integral of 1 on 1 plus x squared dx. Now the dx is cancelled, so I'm integrating 1 on y squared with respect to y, and that's arctan of y plus c, and this is arctan of x plus c1. Okay, so I can move the c's onto one side, so I'll get arctan y is equal to arctan x plus c2, and then to get y, I need to take tan of both sides, so I have tan of arctan of y is equal to tan of arctan of x plus c2. So the tan and the arctan will cancel there. Now in this case, because I've got arctan x plus c2, I can't just cancel that tan and arctan, because I don't have an arctan on the c2, but you can't split up tan across both things inside the bracket. You have to use a special formula, which is not the most important thing. So just because we're trying to find y, I'd just say that's tan of arctan of x plus c2, and I'd leave it like that. I wouldn't worry about going any further. Okay, alright. Now just with this example, let's say we knew one more thing. Let's say we knew that y of 0 is equal to 2. That means that we'd be able to find c2. So when x is 0, y is 2, so 2 will be equal to tan of arctan of 0 plus c2. Now arctan of 0, so what angle has a tangent ratio of 0? Well, that's just 0. So it'll be tan of 0 plus c2. So 2 is equal to tan of c2. So c2 is equal to arctan of 2. And so then my function is y is equal to tan of arctan of x plus arctan of 2. Now you could just leave it like that, but there is some simplification that we can do, because we know that tan alpha plus beta is equal to tan alpha plus tan beta all over 1 minus tan alpha times tan beta. Because both both terms inside the bracket have an arctan, whenever I take tan of either of those, the arctan will cancel, and so it's worth doing the simplification here. I've just got to keep remembering to push the page. So in this case, y will be equal to tan of arctan of x plus tan of arctan of 2, and then that will be all over 1 minus tan of arctan of x times by tan of arctan of 2. And so in all those cases, the tan and the arctan are going to cancel. So I'm going to have tan of arctan of x, which is just x. I'm going to have tan of arctan of 2, which is 2, all over 1 minus tan of arctan of x, which is x, and tan of arctan of 2. So x times 2, which is just 2x. So when both terms inside the bracket have an arctan, and you've got a tan on the outside, it is worth using this addition rule for tan, because the tans and the arctans will cancel out. Okay, and we'll leave that there.